Welcome back to Young Tutor. Today we'll be taking up a very simple topic and a very quick topic, algebraic identities. Algebraic identities are nothing but some simple formulas given to simplify the addition or subtraction of two different numbers. That in other words, all we are doing is just using squares to help us get the numeral quicker. So now let's see some identities. There are a total of there are three normal identities and one identity that's considered to be a special identity, as it contains three variables instead of two. So let's start up with the first identity. The first identity, we usually use A and B to symbolize the variables in this case. So it will be A plus B whole square. Okay, so let's take the example or the identity A plus B whole square. Usually identities are not expressions but are instead equations. So to easily understand how so the actual equation for this identity is A square plus 2AB plus B square. So this is the identity which is nothing but an equation that symbolizes the total identity. Now we can give an identity. An identity is nothing but the variables in an identity can have any value, and by substituting any value, you will get an answer that is meaningful, and this equal to sign will always stand true. In equations, usually you won't have this. As there will be one fixed answer, but here the answer can vary as the variables in this case vary. So this is the first identity. Let's see how can we get to this, or how can we prove that this identity makes sense. So we can write this identity in the form we've learned how to multiply two binomials. In this case, we are doing the same thing. We are just multiplying A plus B by itself. And this can be furthermore written as A into A plus B plus B into A plus B. Correct? So now we can write this again as A square plus AB plus BA plus B square. So in this case, as variables can come in either way, that is AB can be written as AB and BA. So these both will add together and give us 2AB, which means this variable stands true with or this identity stands true. So remember that this is identity number 1. Okay, this is the first identity out of 4 different identities. For an example for this identity, we can take an example for this identity, which will be A equal to 2x and B equal to 3y. So here the variables change, but all we are substituting is A is equal to an x variable that's twice itself, and B is equal to thrice of y. So this is nothing but 2x plus 3y whole square. And using this identity, we can easily substitute the values in these locations, because the question is given is that this is the question, and instead of trying to solve it the whole large way, we can simplify it into this format and quickly solve and get our answer. So 2x whole square plus 2 into 2x into 3y plus 3y whole square. So we can to get the answer, all you have to do is square each single component that's in this in this and squaring this and multiplying these. So all we have to do right now is get 4x square, because we have to put the square on x, plus 12xy plus 9y square. So this is the last answer of solving for this. If we do the larger method, it's going to take more steps and of course more time. So this is just a super quick and simple way to solve this expression. Now let's start up with the second identity. The second identity that we'll be taking up is a minus b whole square. In this case, we can see that there is a difference between the a plus b and a minus b. The only difference is that there's a minus instead of a plus, but this completely changes our answer. So let's see how can we get this, which is equal to a square minus 2ab plus b square. So you can see that there's a plus here because I'll show you how that plus comes there and how the minus comes here instead of the plus that was in a plus b whole square. So let us see how can this equation equal this. Okay, so first you need to remember the rules that we've learned with integers and how minus into plus or minus into minus turns into minus or plus respectively. So we should remember this as it's very important and it applies here in every single of these parts. So first let's start up with a square, which is very simple, and then it goes to minus ab, and then which means we solved this section. Now let's go to this section. Here we have a minus, so it will invert all the signs inside the brackets. So it will be minus a and plus b. I'm just writing it here for reference. And then we can completely omit this minus sign. As it's minus a, b into minus a will be minus ba or ab. I'm using this ab for reference and easier understanding. And then there's a plus b and there's a plus b here. So b into b will give b square. And this of course is equal to what we've already learned over here. A square is equal a square minus 2ab plus b square. Okay, so now that we've got to know where does a minus b whole square, how a minus b whole square becomes a square minus 2ab plus b square. Now let's see an example of this identity. Let's take the example 4p minus 3q whole square. So again the variables might be different, but all we are doing is assigning a the letter 4p for the term 4p, and b is assigned 3q. So do not worry about the minus sign. All we are doing is dividing each variable and assigning the either of these variable a certain value. So now let's take 4p whole square, as there's a square, minus 2 into 4p and 3q whole, and this not squared, plus 3q whole square. Okay, so now that we've now let's simplify this better and get the actual answer. All we've done is given a wherever a is there, we've given the value 4p, and wherever b is given in this section, we've given it the value of 3q. So this is equal to 16p square minus 24pq plus 9q square. So this is the final answer of solving this. We can see that it's a lot quicker than using the actual method and solving it by a binomial by binomial multiplication. It's way quicker and way easier to solve. Okay, so now let's do the third identity. The third identity is a plus b into a minus b. So all we are doing here is taking one term from the first identity and one more term from the second identity, and we're putting them both together and multiplying them. That's the only thing, and this is equal to a square minus b square. It might look odd how squares are getting involved when there are no squares in the question. So let's see how this is equal to a square term, or the negative of two square terms. So we can take this and then we can put here, so a into a minus b plus b into a minus b. In the last equation we had b minus b over here, so all the terms would switch, but in this case we do not have a minus term. So all we are doing here now is a square minus ab or ba plus ba minus b square, because there is a minus into plus, which is equal to minus. As you can see here, we have a minus ba and plus ba, and both of these can be cancelled out, or that is, they both add up to 0. So we can completely remove this from the term, and what we are left with is a square minus b square. Okay, so now that we've understood how a plus b into a minus b is equal to a square minus b square, let's take an example. Okay, so let's take an example for the third identity. Let's take 6x plus 7 into 6x minus 7. So over here the only difference is the plus and minus. Let's immediately so in this case a is equal to 6x and b is equal to 7. So all we're going to do is substitute the same equation into a and b. So we know that this is equal to 6x whole square minus 49, because 7 square is 49 directly. And this is the answer. It's very simple and very quick to do, but of course if we take the longer method, it will end up being a lot longer for us, because we have to do like a lot more complex multiplication and division, multiplication and subtraction. So instead of that, this is a lot quicker to take up, and that's why identities help a lot for us. Now let's move over to the last identity and the final identity, which is known as ax plus a into x plus b. So here you can see that this is the fourth identity, and as I said earlier, fourth identity is a special identity. The special identity stands because it has an x variable, a third variable that comes up, and this variables or this expression's answer is also quite confusing and quite hard to understand, because of how this simple equation can turn up to be that complex. This is equal to x square plus a plus b into x plus ab. So over here we're just taking x on that side for simple terms. So you can the x can be on either side. There's no issue with that. And this is equal. So let's see how does this turn into this. Okay, so let's start. First, we have to do is simple multiplication. And then this is equal to x square plus xb plus ax plus ab. And over here you can see that x is the common term over here. So all we can do is group x together and put a plus b or b plus a aside. That is x square plus a plus b into x plus ab. So you can see what we've done here. We've put the x in the corner and we've taken a and b and grouped them together and multiplied it by x. So we are not changing the equality. It's equal to each other, but all we are doing is just simplifying it for us to understand. Now let's take up an example, a quick example to do this. So let's take the example 501 into 502. Here we are not taking variables, we're directly trying to solve this and getting using this method. So how can we multiply this, because they're quite big numbers and we are not very thorough with these numbers multiplication. So all we'll do is write it as 500 plus 1 into 500 plus 2. So as we can see here, all we have done is substitute x with 500 and a with 1 and b with 2. So we've remembered the identity as this is equal to this, and let's exactly replicate that into our answer. Okay, so we can see that 500 square, we know it, at least it's very simple. It has 4 leading zeros and a 25 at the front. So it's 250,000. 250,000 plus 3 into 500 plus 2. This is equal to plus 1500 plus 2, which is equal to this. So we can see that we've simplified 501 into 502 as this, because all we've done is separated the numerals and we've easily used this fourth identity, or considered a special identity, to solve this equation. So let's start with the first identity. This is the homework. I'll be giving you exactly 4 pieces of homework, one for each identity. So if you don't remember the identity, you can just go back in the video and understand what was the identity. Okay, so the first homework for you, which will be from the first identity, is x plus 3 into x plus 3. That is nothing but x plus 3 whole square. The second homework will be 2a minus 7 into 2a minus 7. The third homework for you will be four x plus 3 into 4x minus 3, And finally the fourth homework will be 1001 into 1010. Alright, so it's very simple homework. Go ahead and try it on your own. Thank you for watching. The channel name is Young Tutor. If you really like the video, then click the subscribe button. Thank you for watching.